The work 5G campus network factory floor measurements with varying channel and QoS flow priorities from 5 gearing project is supported by FFG Austria. With the latest releases of 3GPP, 5G, especially as a private campus network, seems a promising solution for many industrial applications which require reliable and low latency wireless communication. In this work, we provided a deployment solution for a private 5G network on a factory floor and explained step-by-step testing procedures of the most important communication parameters for industrial applications. In order to have the optimal solution, the right 5G deployment, estimation of capacity and performance, as well as comprehensive and reliable testing are crucial. For coverage measurements, the first steps are proper labeling of the coordinates of the factory floor and the definition of the parameters we want to measure throughout the factory floor, such as received signal power, SNR, latency, or throughput. The next step is writing a programming script for automated acquisition of the wanted parameters and saving the data locally or in the cloud. In our work, we measured all the parameters on the UE side. After the mentioned steps for the preparation, we can start our measurement campaign throughout the factory floor. We can measure the defined parameters at any labeled spot on the factory floor. After the measurement campaign, another script for presentation of the measured data is needed. In our work, we used two-dimensional heat maps to match the measured values with the factory floor. Additionally, we measured throughput and latency performance in several scenarios with varying traffic loads, traffic patterns, channel conditions, and different 5G QoS parameters. For these measurements, the first step is to define the scenarios of interest in terms of number of UEs, traffic patterns, location of UEs, etc. After that, a script for traffic generation, acquisition and extraction of the performance parameters is needed. An important part of accurate and reliable one-way latency measurements is synchronization. We measured end-to-end over-the-air latency in both uplink and downlink directions. For this purpose, we used the PTP synchronization mechanism with the accuracy in the range of nanoseconds.